this video, we will learn about sets. The definition of sets is: a set is a collection of distinct elements. Distinct in this case is important because every element needs to be different, otherwise it will not be classified as a set. No element can repeat. I'll give you an example of a set, which we can name M. Each set needs to be denoted by a capital letter. In this case, I'm going to use M. So, M is equals to, in curly brackets, 1, 2, 6, and then curly brackets close. This is a set. The order of the numbers does not matter, and the elements cannot repeat. To show which element is in the set, we can write 1 belongs to M. And then if you want to show that it does not belong to, so you can do 7 does not belong to M. This sign means belongs to, and this means does not belong to. There are finite sets and infinite sets. We can learn about them by using an example. M is also a finite set, but we'll do another example. Sets of all positive integers. Now, if I leave it over here, it will be an infinite set, because positive integers can go on forever. So, this sets of all positive integers is going to be capital letter O is equals to curly brackets 1, 2, 3, and then curly brackets will be closed. This is our infinite set, because positive integers can go on forever. And if you put a range on it, in this case we can do less than 50. Sets of all positive integers less than 50. So O is our infinite set. And then sets of positive integers less than 50 is going to be N is equals to curly brackets 1, 2, 3, into 49, because it has to be less than 50, not till 50. Now to define and show what sets elements are, we use set builder notation. So we will learn how to use set builder notation. So let's first try to define a set we already have, like N. N is equals to curly brackets X, such that X belongs to all positive integers and X is less than 15 and curly brackets closed. This is the set builder notation for our set M. Another example of set builder notation we can do is B. B in curly brackets is 3x such that x belongs to all positive integers. And then curly bracket close. In this case, the values of B will be 3, 6, 9. And then goes on forever because it does not have a limit. This is an example of infinite set. Now we'll talk about 3 more types of sets: empty null sets, equal sets, and subsets. So first, we'll do empty and null sets, which we can do is use set builder notation to define it. E is equals to, in brackets, x such that x greater than equals to 0 and x square is less than 0, in brackets close. There is no value that satisfy this set presentation, hence E will have no value. So E will become a null or empty set. Empty brackets can also be used to show that it's empty. Another example can be C. C is set of months starting with Z. Now there is no month that satisfies this because no month starts with Z for the 12 months. Hence it will be a null set or empty brackets, which shows it's empty. Now let's do equal sets with an example. So capital P is equals to X such that X belongs to all positive integers and 5x is less than equals to 16. Then members and elements in this set are going to be 1, be 2, and it'll be 3. Won't be 4 because 4 times 5 is 20, which is greater than 16. So we'll have 1, 2, 3. Then another set is Q, which is going to be equals to X such that X belongs to all positive integers and X square is less than equals to 15. Now the members and elements of the sets are going to be equals to 1, it will be 2, it will be 3. Won't be 4 again because of the same reason above. 4 square is 16, which is greater than 15. Now P and Q both have the same elements, hence they are equal. So P is going to be equals to Q. This explains equal sets. Now let's do subsets. Let's suppose we have a set R. R is equals to 1, 2, 3, 4, and 5. And the other set can be just maybe on top here we can do P. P or Q. Let's do P. So P has the values 1, 2, and 3. All the elements in P are in R. Hence P is a subset of R. And because we know P does not have 4 and 5, hence P is a proper subset R. If we didn't know, then it wouldn't be a proper set. It'd be like it had a line underneath. Now let's look at all the properties of sets. Suppose we have a set A, this could have any values, but so any set has these properties. Starting with null set is a subset of A. Another property sets have is A is a subset of A. Two more can be if A is a subset of B, then number of elements, which we can write as n, number of elements we'll do of A. To explain number of elements, can show you on top. Like number of elements of P is equals to 3. So number of elements of A are less than equals to number of elements in B. And then if A proper subset, then number of elements less than number of elements in B. It won't be less than equals to this time because it's a proper subset. We have learned about sets in this video. In the next video we will do Venn diagrams and learn all about different types of Venn diagrams. So I'll see you in the next video. Bye.